Thank you, Bethany. It's really nice to be here. Good morning, good afternoon, and good evening to you all, wherever you are in the world. Thanks very much to UVA and TYDE and to UCI and CERES for the invitation and for putting on this wonderful workshop. I've learned so much already today, so it's lots of fun to be a part of this. I'm going to try to be a little bit of a provocateur as we go through, but also sort of underscore a lot of the things that have already been said today so far. First, disclosures. I've got thanks to all the institutions and the funding agencies who allow us to do this work, and to the many, many people who have been involved. As all of the teams have shown, like it takes a lot of people to do this kind of work, and so I'm honored to be a part of that group and to be here presenting to you today. And also to highlight in particular Sharon Sun, who's talking next, who will also be talking about some of the same stuff that I'm opening up with today. Okay, a couple of years ago, I took part in a conference which was similar to this one. And there we created a paper about digital trace data collection for social media effects. And in that paper, talked about 3 different types of ways to get those data. APIs and characterizing those as being platform-centric. We talked a little bit about that earlier today. It's talking about data donation from a user-centric perspective, but also from a platform-centric perspective, getting one platformer at a time, though I'm amazed at the ways in which you all are able to grab from multiple platforms now simultaneously. And then the third group being tracking, also user-centric, but potentially across platform, because you're sort of going in at the OS level or at the device level for smartphones. Much of what I'll talk about is at this level. Just want to point to a paper, a primer, a methodological primer on how to extract meaningful measures from that smartphone log data. Doug Perry, I think, here is in the audience, and so just a shout out to that group on the ways in which they're allowing the rest of us to also follow in their footsteps on how to extract meaningful data from those data streams. So I'll talk about 3 ideas in the brief time, hopefully to get to some questions. Talk a little bit about dyadic conversation dynamics and how we use data donation in trying to do that work in the traditional sense in which it's being talked about here. Then I'll talk about the Human Screenome Project and how is it that we're also trying to make use of those data. I was impressed by Amy Orban's team and the struggles that they're having with extracting meaning from complex data, which we're running into many of the same things. And I'll make a couple notes about ethics at the end here. Okay, so prompted by the invitation to come here and talk about data donation, I was reminded of a Mimi Brinberg, who was a student with me at Penn State, was doing for her dissertation, was interested in how new romantic couples use more similar language over time. So following from communication accommodation theory, the longer we get to know somebody, we will start to match our language together. So this was a true data donation project, user-centric and platform-centric, using one of these data download packages, the iMessage Analyzer, in order to be able to get iMessenger from off of iPhones. And here's just an example of one of those. The theory is that the language similarity in those text messages that we expressed in the short term, message to message, should get closer together over the long term. So the study design was like this: the TLC, the Texting Life of Couple Study. At a lab visit, the dyads, both members of the dyads, came into the laboratory, did the consent, and then one of them would go into the iMessage Analyzer, download the iMessage for that particular conversation between the dyad, both members being there in the room and providing consent for which of all of those messages that they would like to share with the research team. So this was bringing in 41 couples, getting about 1 million text messages there, data cleaning. We went through the same kind of de-identification process, removing names, addresses, and other sort of identifying information. And what one is left with is a decent amount of messy text. I want to highlight this as part of the data cleaning process because many of the decisions that get made about what to do with that messy text have influences on how it is that the analyses proceed further down the line. In this case, we used daily language style matching to try to get what the linguistic similarity was between the 2 members of the dyad, and then fit some exponential growth curves to see if indeed they would reach some asymptote towards the beginning of when that relationship formed. So the couple on the left, you can see sort of they reached the asymptote right when they declared themselves to be a couple. The couple on the right reached the asymptote shortly before. It is a couple months before it is that they became officially declared as a couple. So that's sort of a text analysis of data donation coming from single dyads, small samples, pulling together through one of these data download processes. We've also done this with corporations. So we were interested here on how it is that conversations via an on-demand, peer-to-peer emotional well-being app might be associated with emotional improvement. We had a contact at this company who was forming a new, at that time, peer-to-peer well-being app, and we were able to get data from them and made sure to negotiate on the front end of that sort of a priori explicit permission on the publishing of what we found in those data, so that we had no conflict of interest, and also that we had no constraint on what the findings might be, whether or not we would be able to publish that work. In this case, just to give an example of sort of what the data comes to us like, a bunch of JSON files has been talked about a lot already today. And then this is pulling them into R, and within that chat messages column there, you can expand in there and we can get the back and forth of the particular conversation. Here we got relatively clean files. Would indicate here it's a little bit less messy text than the text message text, and that's probably because the listeners who are being provided by the app also are often working through a keyboard interface, which leads to less misspelling errors that exist in those data. One of the big challenges that we encountered both on the analysis side and on the theory side is what to do for document size. And you see that some of these text messages are very short. Should they be treated as one document, or should we move up to capture a large number of words before we do the analysis, the language analysis on these? So what is the temporal aggregation it is that we should use? In this case, we went all the way up to the conversation level, and one of the nice things about working with this company was that we got an original tranche of data as they were starting to build the app. And then later on, after they had fully launched, we were able to get another tranche, which allowed us to be able to do a replication to see if the results that we got in the first tranche also held in the second tranche as well. And they were very generous in providing all of this data to us. We found that on average, certainly support seekers felt better after the conversation, and some indication that the language style matching is a mechanism by which the listeners are able to provide better support for the people that they're listening to. Okay, so that's sort of the first part here, just on data donation in the traditional sense. And now I'll try to introduce the provocateur part of this, which is what we're calling the human screenome project. So just a little warning here that this is meant to be emotionally arousing content, which we know that social media is, and that is probably one of the reasons why it is effective at capturing our attention. What we're doing in this project is we are installing software on people's smartphones so that they can donate screenshots that are taken every 5 seconds as they go about their daily lives. So here we've now collected about 4 centuries of data. This is data from one of our research assistants in the laboratory who has created a persona in order to go through what a typical day might look like. And granted that this depiction is in part built to make sure to include the emotionally changing content on all 4 aspects of the valence arousal spectrum, but also as sort of a U.S. normative white sample of how it is that that kind of media is being displayed. So be aware that this is also sort of constructed in a way for us to be able to represent a particular type of way in which people are engaging with content. We were particularly interested in how the emotional valence of these different pictures that people are being exposed to are manifesting in this space, and whether we could analyze that in an automatic way. Okay, shout out to my PIs here, Tom Robinson, Nick Haber, Byron Reeves, and I, who have these NIH grants too. And Sharon, in the next session, will talk about the follow-on grants that she's gotten in order to be able to use this same method. Okay, so from that, we're able to extract out this very high rapidity of information. Each row here is a day. This is an adolescent And this is 1 month of data, so it's 30 rows there across 1 month, and black is when the screen is on, and white is when the screen is off. You can see just at that very granular level, even on off of the screen, you can see that there's many, many hours of time spent on these devices. And this is not just social media content, but all of the content which surrounds social media and how people are traveling from that content into social media and where is it that they go next. Adjacent to the screenome data, we're often collecting self-report data via questionnaire, both in EMA type designs or on less frequent time schedules. I'm going to try to treat this data both as big data and as small data as we go forth. The challenge here is how do we extract out meaningful information from these data. Now, you also want to be able to collect these data, so we've just recently open sourced our app. Ian Kim, a postdoc working with us, has built an open source platform that allows for this digital trace collection, and you might consider this as data donation, and indeed the sort of legal ethical pieces which surround the collection are in that same framework as we've seen elsewhere today. This has both the researcher side apps and user participant side apps, very careful on how it is that the authentication and encryption is happening along the way, but we get both sort of JSON-oriented text data and also a bunch of image data from those screenshots. So there's a bunch of modules that you can put with this in order to collect all the different streams which are available from the smartphone. So basically somebody is donating tracking of them full-time out in the world, and it's built in an open source way so that other groups can also add additional modules in that they would like to do. Highlight here up in the right-hand side, there is a button that you can turn on and that the user can turn on and off the app, so that this is important in order to be able that they have control over both the privacy and that they have agency in that sense. I'll talk a little bit more about this later, but here's a link to the website, tinyurl.com/screenomics, in order to find out more information about that platform. Okay, so that introduces the Human Screenome Project. We've collected now about 3.5, 4 centuries worth of media use. And the idea here was to not just get the social media content, but to get all of the content comprehensive across all the different platforms for one person. And I'll push for a little bit here on the person-specific analysis of such kinds of data. So how is it that we're making use of these data? Similar to other groups, we are able to use computer vision in order to pull out a variety of different features. Here's a low-level graphical feature. The screenshot on the right has relatively uniform color, mostly black. The screenshot on the left has a larger color distribution, so we can say that the entropy in the color space is larger. This may be some kind of a proxy for the amount of cognitive processing which is needed at any given moment in time to be able to process that information which is on the screen. So then we get these wonderful time series about how is it that people are moving through the complexity of the image space. We can also pull out high-level graphical features. So here's object recognition for persons, cell phones, cats, dogs, etc. These can all be pulled out using sort of off-the-shelf computer vision models applied to this repository of screenshots. And one way in which you can do that, we have this notion of social media sensitivity, and so that's how is it that my affect is changing in relation to my exposures to social media or particular aspects of social media. But we can think of other things also that are appearing on the screen. So here's Michelle Eng did a paper looking at nature sensitivity, whether we have higher well-being in the moment after we have been exposed to nature-related content. And so going through all those screenshots, identifying the nature-related content and relating that to the EMA self-reports that are being obtained afterwards. And notice that here, there's sort of a flat effect, but there's lots of heterogeneity across people and how it is that they're each responding to that momentary tech nature exposures. Okay, just to give here now, all these different screenshots can be placed within a space. Here's a variety of different ones that are supposed to theoretically evoke different kinds of emotional content, both from negative content to positive content feelings from that. So cats in particular are driving our well-being up in many cases. So can we do this at scale? So here's our screenshots that are passing through at high rate. We can use a deep affect model in order to project each screenshot into this two-dimensional space given by affective valence and affect arousal. So in essence, this is like using the large language model as a rater if we had humans rating all of these screenshots using the large language model as the rater. And we can see that there are projections into this space. I do want to highlight, which has already come up earlier, algorithmic bias being embedded here. And you can see quite clearly that this manifold in this space has a clear edge to it. And that's part of the way in which the model is built, that it has some regularizations in it that sort of force those edges on there. But we do need to be careful about misidentification of the faces that are in there and the emotions that are on those faces, and whether there's out of distribution transfer that was a model which was built on very clean pictures. How does it apply to screenshots? Our conclusion from this was that it's sort of semi-reliable match to what human raters do, and that it indeed has signal in it, so that we can start to look at how is it that people are moving around in this two-dimensional space. I'm calling this a digital footprint to underscore the idea that on a given day, we may step into the media world with a particular footprint, and that on the next day, as we travel through and go forward, that it might change. And that's different from a fingerprint, which we think of as being static, that the footprints have some dynamic quality to them. And so then we can look at how is it that those digital footprints are changing over time. One can think of this as a super intensive burst design. One of my mentors at UVA, John Nesselrode, was instrumental in developing the idea about measurement burst designs. And now we can say, oh, we have continuous data, so we're actually in this very intensive burst design space. The question arises again about what level do you aggregate temporally as we go forward here. Okay, so other ways in which we can do this is now, instead of using the LLMs as a rater, we could also use the LLM transformer architecture itself and leverage its capability for very high-dimensional work. So now we can take the screenshots and we can project them into a CLIP model here, which is contrastive learning image pre-training, which takes every screenshot and sends it into a space which is defined by 768 dimensions. And this space was trained off of image caption pairings. So we can now query with natural language all the different types of images that might be in there. So now I can type in cat and it will arrive at the cat pictures. The idea here is now we can get one person's trajectory into this 768-dimensional world to learn how is it that they're moving around in the social media world and all of the content which is surrounding social media. So this is very exciting, and my students are very excited about working on these 768-dimensional models. But I want to confess to a sort of small problem that arises here. We spent what I now consider to be an embarrassing long amount of time on trying to interpret these 768 dimensions and or reduce them down to lower dimensionality where we might be able to get some interpretation. But I want to highlight that the way in which these models are constructed, those 768 dimensions are, unlike principal components analysis, they are non-orthogonal and also non-linear. So any dimension can be moving, but not just straight lines, but they can be moving in a wide variety of shapes themselves. So one can consider this 768-dimensional space as being completely unburdened by any theory, no substantive theory, and also maybe even no statistical theory. We're trying to discover now what is it that these spaces actually mean that we're getting from these large language models. So this small problem has manifested in that kind of stuck at this point about how is it that we interpret now that we can get these beautiful projections into this space. So one aspect of this is now we can say, well, we've created an immensely beautiful piece of abstract expressionism, and now that we do that, we can compare ourselves to the artists, which are also doing expressionism by leaving drippings of paint all over the canvas. So our participants are doing similar things in this 768 dimensional space. Given this problem, one of our students, Yikun Chi, came up and said, well, you did this paper back in 2017 on comparing two-dimensional personality spaces using Earth movers distance. And that's basically how is it that a person's movement in two-dimensional space differs from another person's? Can we apply that here in the 768-dimensional space? And the idea is that even if we don't know what content is changing from week to week, we can still quantify how much that distribution has changed from week to week. It turned out to be sort of needed to change the distance metrics a bit in order to become computationally tractable in this large space. But then you can see, are the week-to-week changes in the distribution that people are expressing on their phones related to changes in their mental health. And here we realize that the analysis must also go person-specific. So when you get this much data, it's not the case anymore that one model holds for everyone, but different models hold for different people. So in a truly person-specific analysis, where each of these 11 people are analyzed separately, we do see some relations between week-to-week or fortnightly changes in mental health, along with fortnightly changes in the content of this distribution, however that distribution is changing. And that's happening in a different way for different people. Pushing that a little bit further, we can also then start to put some of these nonlinear models between the embedding spaces and our outcomes, in this case, mental health fortnightly depression scores. Here again, we saw that if we ran the model for all the people at once, sort of as a multi-level model, we get very little prediction there of the association between screen content and fortnightly changes in depression. But if we do individual level models, person-specific models, we see that we find some relations between at the individual level there. So sort of questioning whether or not we should be, as a field generally, once we're able to get these rich data streams, still relying on traditional group level analysis, or instead moving to truly person-specific analysis. I'll push for the latter. Okay, this still doesn't help, but so we're really interested in how is it that we can get at the content area. So Merva Sarit, another student, has developed a pipeline where we now use the large language models as you would interact with them through ChatGPT, et cetera, in order to be able to get descriptions of all of those screenshots. So these are built on all open source models like the Lava 1 Vision model, and the idea here is that we query asking the LLM to describe a screenshot for us. It provides a multi-sentence description of that, and then we start to cluster those together based upon what those descriptions are. She's built a wonderful interface. So now you, with all your screenshots, you can also apply this. It's all open sourced as well, and built a wonderful interactive interface that would allow any researcher who's interested in particular kinds of content to be able to go in and identify the screenshots that are associated with that particular content. So we see all these different clusters here. So here's mobile news feeds, Chinese navigation apps, financial management, food delivery or ordering, all the different ways in which people are interacting with the content that exists in the digital world. So now this should open up the space for when I have a specific research question, I can go into here and find the particular clusters of screen content that I'm interested in and how those relate to my particular outcome of interest. So that's exciting. And what that might allow us to do then is to have deep insight into these individuals' digital lives. I put this in here both in order to highlight that this is 24 hours of one person's smartphone use that gives us maybe an insight not only into their digital life, but also into their soul. And that at the same time as being exciting is also a little bit scary on how it is that we're able to see so much that's getting manifested on these screens. So to highlight the sort of value, ethics, and risks part, and we can think of this paradigm as being a balance between the value of the data and the risks associated with the data. So we get this rich repository that might now be able to give us new insights about many, many topics, the symbolic representations of all of life that is expressed in this digital form. And you have to go through a lot of hoops in order to be able to get those kinds of data. So human subjects IRB, both on the non-medical side and on the medical side. And at Stanford, all the offices related to privacy, information security, intellectual property. We had many, many conversations with faculty, administrators, engineers, the legal teams, industry consultants, and both the participants and the non-participants to try to understand why people were participating and also not participating. Many of the things which we've seen in the earlier presentations also manifested in our conversations with these different stakeholder groups. Along the way, as the last presentation also noted, is that the continual monitoring of the infrastructure and the processes and updating the encryption, storage, and access in ways that are coincident with how it is that the data are being collected and what the new ways are and standards on how it is that you store and provide limited number of people access to those data. I want to highlight here also that we were careful and encouraged to bring on bioethics scholars onto the teams as well, and that produced a interest in producing white papers and potential use cases on what the long-term implications were. And at certain points in the progression of the project, we might have even decided not to do the rest of the project. Beyond the regular trust and sort of privacy aspects that we often engage with in our ethics conversations and have here today. I want to also highlight, come up with in a few questions, the justice and equity issues and also the beneficence issues on how it is that we are providing some information back. I was very excited about the dashboards which are being created that allow participants to be able to look and interrogate their own data. Where we've ended up on that is the need to facilitate this independent research, as everybody here is engaged with this data donation process, as being something which is independent of the for-profit corporations. And one could consider that we have a moral obligation in order to be able to do this work outside of those institutions so that we can also learn things about people and have some access to the same types of data streams that often exist within those houses without any transparency to them. So I'm excited to be here and enjoy the conversations with you, and also to say, like, wow, it's amazing. The digital world is this amazing universe of things that we haven't seen before. We don't always know how to characterize it or how it's influencing people, but people are making their way through this world, and we have an opportunity in order to see much more of it now, and also to try to make sense of it in order that we can design interventions that will help people to optimize their own lives and goals. So, three general things here. I talked about data donation in the traditional sense, introduced the Human Screenome Project, and our way of producing super intensive longitudinal data that chronicles all of a person's digital life. And then some ideas about the ways we're digging into that content and trying to make sense of the nonlinearity in this massive space, and always considering the ethics of how it is that we're collecting and using those data. So thank you very much.
Fantastic. Thank you, Nilam. What an amazing array of methods and approaches you've just done an overview of. I've already gotten comments coming in of people saying they're very excited to watch the recording again to get a reminder of all the different pieces. So let me jump in with a couple of the questions that have come in, and I encourage others to keep adding. First was earlier at the beginning, you showed some of the work that you did with the emotional well-being app with the sort of collaborating with the company. Can you talk about how you established the data sharing agreement and publishing independence agreement that you mentioned in order to be able to do that work? Because I know lots of groups have struggled to get those in place and in ways that are workable.
Approach it very much as we do with other collaborations which are interdisciplinary, and the idea that each of us who's involved in that collaboration has different goals. and we would all like to achieve something which is useful for our side or in my particular field. When I collaborate with musicians, they would also like something which is useful in their field. And so having those conversations very explicitly, I think we were lucky in this case that they were right at the beginning of launching that app. And so they were very open to help us figure out how it is that we can do it better. And so it mostly was just having open conversations, and I didn't find difficulties in that particular relationship on how to do this.
Great, great. Can you talk a little bit about how you're training the rater? Is it fine-tuned? If you look at that question, they had a few sort of more technical questions.
Oh yeah, sorry, let me pull that up here. In the first round, we just use off-the-shelf models with no training at all and judge the accuracy of those on small sets of human-coded data, which we produced afterwards. In the latest round, we are also producing some ground truth data and then taking off-the-shelf models and fine-tuning them in subsequent steps. So to take like two layers before the end and then try to use that in order to do some fine-tuning afterwards. Oftentimes, or in some cases, with multiple models used in order to fit different parts of the out-of-distribution pieces that might work in different ways. But I'm a little bit on the side of we're moving fast in order to try to obtain some meaning out of the data to unlock pieces of it. And if I don't have perfect data on the other side, as an analyst, I'm comfortable with having an error term in my regression models. And so I'm often tolerating not perfect ratings in order that I can try to find some underlying dynamic trends, because my real interest is in the dynamics. And so I'm trying to get to those dynamics faster than might always be useful in other settings where it's very important whether one got the classification correct or not.
No, that's helpful. Some related questions, but can you describe a little bit more how you compared the human categorization to the models, category, sample size, different pieces of how you went about doing that?
So we would, so all of the data which we collect in this Chronomes project is extremely private, and we're not allowed, we are not able to, we don't want to also use those in order to do crowdsourcing of rating. So we would not, for instance, put them onto Prolific and ask many human raters to rate what the emotional content is of those screenshots. So we have, like the video which I was showing earlier, produced our own sets of screenshots in order that we can ask humans to rate those and then do projections into this larger space there. In the Media Content Atlas was built off of open source tools that are already about 1 year old now. And the latest generation of Gemini, GPT-4o, are very good at providing detailed descriptions of these screenshots. So I'm almost convinced myself that I don't need to do as much validation on the other side, because the spot validation, it really is amazing how good the models are.
Interesting. Can you follow up on that about what you see as likely boundary conditions of what those systems will be able to classify well and what they won't be able to classify well?
I would say with some prompt engineering, one can, so one of the problems which is encountered is I have a battery signal which is up on the upper right-hand side of my phone screen, which I am not interested in for most of the questions which we are asking. And the large language model can get distracted by that battery signal when I'm looking for psychological import of what is the content which is on the screen. But with some prompt engineering, you can get it to concentrate on the parts of the screen which are of potential interest for a particular psychological issue, and then identify not only what's on that screen, but also what is the user doing across a series of screens. A person may be trying to figure out where to have dinner tonight, with negotiating a location meeting. And it's quite good at pulling out all of these. I'm haven't explored far enough to be able to say, okay, where are the boundary conditions completely? But that space is so huge that sure we'll encounter them at some point. But
Right.
I believe we're way further into the details than social media versus not social media. And you can see
Mm-hmm.
many of the groups here today are trying to dig into the content very specifically about what is the actual language work which is happening inside of those text messages that may be indicators. I would highlight there that we find in that language analysis and also in the screen analysis that the user's intent appears to be changing extremely rapidly.
Mm.
So the exact same image may produce a social comparison on one moment, and 35 seconds later, it may produce a different feeling about, oh, this is my friend and how wonderful she is. So being aware that within person, the interpretations of the same image also may be changing over time.
Yeah, absolutely. You made a reference particularly tied to some of the open source materials, but can you talk a little bit about how you're managing the fact that the tech is changing constantly and ability to access different platforms is changing, all of those kinds of pieces, and how you sort of try to be responsive in those ways?
Yeah, so we've similar to how it is that the APIs are changing in order to be able to access the large data companies, and how is it that even we saw in the first presentation today, the interfaces by which you download your own data from Snapchat or Facebook, Instagram is also changing from week to week, potentially. So how to stay involved there becomes an issue of always monitoring that and having a team in place in order to be able to monitor that. We moved to Screnomics in order to be able to not have to work with each platform separately. That if we just got the content which was on the screen, arguably then that was manifesting the fluidity with which people move from one platform to another.
Mm-hmm.
In an earlier presentation, it was noted that people have particular kinds of conversations on one social media app, and then they have other conversations on a different social media app. So in our Screnomics project, we can see that fluidity of movement and when it is that
Mm-hmm.
even within a dyad, they switch between content. And amazingly, you see those conversations and it will be 3 messages in text and then 2 messages in Snapchat and then 3 messages in Instagram back to text. And they're just moving. It's the same conversation, but on all these different platforms. And if you don't have access to all of them, then you would be missing some content. We've located on Android. We don't have a way yet to do continuous screenshot taking on iPhone. It seems the OS is locked down in a way in which doesn't allow us to be able to get in there to take those. And we are keeping track of the OS updates in order to be able to update our code so that others can deploy their apps also with the changing in the interfaces on the OS level
Right.
rather than at the platform level. So we're only dealing with one OS versus dealing with many different platforms.
So that ties into one of the questions that came in of, do you think it will ever be possible to get this data from iPhones?
But there are ways to take recordings of single sessions. That already exists. My hope is that at some point along the line here, we will be able to engage in collaboration with Apple and Google in order to be able to obtain directly from the OS the information which is on individual screens. And that would be my hunch is that the field is moving in that direction in order to be able to produce AI agents that help me work on my screen. That's already
Mm-hmm.
emerging. And so if that can be opened up to the research community, that would also be very beneficial. We'd be very interested in having those conversations on how to do that
No,
with
absolutely.
the engineering teams at those companies.
Mm-hmm. Okay, well, question came in. It seems like emotional reaction to what is on the screen may differ based on whether there are personal relationships between the people in the image and the viewer. Is there a way to code for that in the data?
We, in our original analysis, so yes, indeed, it is the case that the emotional reactions are different depending upon who's on the screen. And I believe that there are also examples of when even the same person on the screen will produce different reactions from me at different times. So it's even fluctuating within person what this emotional reaction is. I presented a view of trying to get to a person-specific analysis. The way in which we are coding faces currently is that we simply know that it's a face, that it has an age and it has an emotion, but we have not coded like, is this the same face or is this a celebrity face, the same face, which is appearing over and over again. Those models are certainly possible to do, and it would take a student who's really interested in that particular aspect of the data to just go in and do it. It would require that one does it at a person-specific level because the people who are repeating on your screen are different from the people who are repeating on my screen.
Super interesting. Yeah, it'd be remarkable to get to that stage. What question do you feel the research field is not asking right now that you feel they should be asking to really move this work forward?
Our hope was that we would be able to dive deeper into the specifics of the content which is on the screen, and to do that in a way which is accommodative of both text and what we can learn from the language, as well as the pictures, which might be worth 1,000 words, each of these pictures. And we've had trouble in trying to be able to understand what are the specific features of the media which people are responding to at any given moment. Media pictures and text are sort of infinitely describable, and trying to locate what are the important features for a particular person. I'm trying to move towards person-specific theories rather than these general theories.
Spoken like a true John Nesselrode student. So you mentioned briefly that, sort of the interest ultimately in moving to intervention spaces. And I wonder if you can talk about the steps to get from here to there from the vantage point of like being able to do the coding interpretation in real time so that you can have like event-driven interventions and move into that just-in-time adapted intervention space. And what do you see as the key steps that still need to happen to get us there? Because I think that is a little bit of the holy grail, right?
Yeah. So I think we're actually quite close. In the latest redesign of our app, Ian Kim built it in a way that allows for parallel processing and an on-device processing of those images. So let me just paint a scenario that we're looking at right now, which is the amount of negative content which is appearing on my screen may have an influence on my emotional well-being. Can we ask people to take a break when the negative content is accumulating up to a certain threshold, and add some friction into the system that says, go do something else for a little bit, and let your tank reset, and then you can start accumulating negative content again later. This requires on-device OCR, optical character recognition of the text which is in each of those screenshots, and then doing a sentiment analysis to try to figure out how the negative words are in there, and then keeping a running count of that. We think that it is not so computational demanding anymore that can be done on device in a closed loop way. So we're currently designing that system, and we'll try to test that out to see if it will work. If that does work, then it becomes a theory matter of what is the particular features that we should be tracking in this cumulative way over time, in order that then when they reach particular thresholds, we can adaptively deploy an intervention. I'm not even sure we know particularly what are the interventions which would be useful in the moment in real time. We know that if you add lots of friction into people's phones, they will just simply move to a different device.
Sure.
So I'm trying to figure out the ones which will be effective for that particular person, and to do it in an adaptive way so that we can locate those moments when they might be most receptive to that intervention.
No, I think that's great. And just as a preview, on the youth panel, we have some members who participated in a hackathon that TYDE did, where they were the youth, it was teens and college students together, were asked to, if you could design a digital intervention for when teens are doing negative social comparison online, what would you have it look like? So we've been trying to get teens ideas about like what should those interventions look like, but
Yeah.
long way to go in those spaces, but I agree with you. Can you talk about, because you are moving very rapidly to this kind of real time analysis and positioning to be able to do those kinds of, immediate responsiveness, how you're managing or how you're thinking about sort of the challenges of working with material that you don't want included. So like nudity classifiers and stuff like that when you're doing it. I'm not sure at what point in your pipeline you're kind of identifying the material that is problematic because you're doing it continuously and in real and moving to real time. So can you just talk about how you're thinking about some of those pieces?
Yeah, so when we started out, we took the approach, we don't know what the problematic material is, and we don't even know how people are engaging with that material. For instance, the graphic content, the violence content, etc. And part of what we were after was trying to have a platform where we could understand what the exposures actually are, what the durations of those exposures are, what the sequencing of those exposures are. So we took the approach of getting the data in a way where it's completely locked down without doing de-identification along the way. That means, yes, we cannot share those data with anybody, and we are only able to look at it within a very secure enclave. But it allows us to be able to start making some statements about what the actual exposures are, how big of a problem is the exposures to these. And I'm less convinced now that it's about particular content types, but that people are using those content types in ways in which they are self-regulating and choosing to engage in that content with its particular times, which is useful for them and what it is that they're trying to optimize. So without making judgments a priori about what is problematic or non-problematic content, trying to identify at an individual person-specific level when is it that they engage with content which might be more problematic than other content.
And a little bit tied to that, I mean, I think I'm curious about what you're learning about sort of likely reactivity to being monitored and things like that. I mean, you have an advantage of it's a passive app that's going in the background, so it's not intrusive, like saying stop now and take screenshots kind of thing. But what have you been learning about, or your inferences about how people might be changing their behavior if they know that the app is running? And I understand they can turn it on and off and things like that, but can you talk a little bit about what's coming up in that space?
Yeah, so in our post participation interviews, and also in the interviews in which people are talking about before when they why they choose not to participate, that we get indications that there are particular kinds of content that are often produce feelings of like, oh, reminders about, oh, I'm being watched. And those have to do with text messages to close others and with financial information are the two key areas that appear to be providing when people are turning on and off the collection of those of the screenshots. When I go into the data, it's really hard to find any evidence of the reactivity effects, even though participants are telling us about them. And that one might think that there's certain socially desirable content, and that may the potentially socially undesirable content may disappear for 3 days or so at the beginning, but then will re-enter into the stream a little bit later. These are participants who are fully aware of everything that is happening on their devices, et cetera, and they have chosen in order to disclose that information. And so we do not see that in this population that is participating much evidence of the reactivity.
Super interesting.
When I done it for myself and I've
Yeah.
gone into those screenshots, there are these two areas that I have deleted screenshots out before I would show them in public, but those are the two areas that are sort of manifesting.
And what proportion of people you invite to participate consent in that sense? Do you have a sense of like who's saying no? The selection bias question is obviously what I'm getting at here.
Yeah, so once people get into the room to do the asset and consent procedure, we have about 66 to 80% uptake.
Okay.
I would compare that to if I do a muscle biopsy, which is sticking a 12 gauge needle in somebody's leg, that's a 25% uptake. So this is not perceived as being as invasive as the muscle biopsy is. And I would underscore something which came up in an earlier presentation, is that the people who are participating are eager that their data are being used in a way that they know who is using it and what it is that they can do it, which is different than the clicking I agree for many of the other
Totally.
companies in which they're already providing data to.
And we've seen people be really expressing pro-social motivations about wanting their data to be helpful to others and things like that. Folks who've made suicide attempts showing their text message history, and we thought for sure they wouldn't want to do that, but knowing that it could be helpful to others, people will.
Right.
Yeah, it's yeah.
I want to come back to one note on the iPhone question, is that we get this a lot because our app is only on Android. I would note that the majority of the world are Android users, and that in the US there is an SES gradient associated with Android and iPhones. And so in principle, iPhone might be the more, Android might be the more generalizable platform if one thinks about worldwide representation.
Super interesting. Yeah, thanks. Well, I think that's a great note to end on. Thank you for sharing amazing work that you're doing and being so open to so many questions. We are going to take a 9 to 10 minute break now, and then definitely grab a coffee, take a bathroom break, because then we'll have 3 short half-hour talks to wrap us up. So a big thank you, Nilam. Really appreciate you joining us.
Thank you very much for the invitation. Wonderful workshop. Thank you.
Great.